Question 10 is coming from circular measure. The diagram shows points A, B, C lying on a circle with center O and radius R. Angle AOB is 2.8 radians. The shaded region is bounded by two arcs. The upper arc is part of the circle with center O and radius R. Then the lower arc is part of the circle with center C and radius R. So center C here, and then the radius capital R here. Okay, so this is the arc they are talking about. The center is here. Okay, so even this one will be capital R. And then they say that state the size of the angle ACO. Okay, now let us begin. So this one is going to be capital R. Okay, if this one is R, even this one is going to be R. Not so? Okay, because this is the center, then the circumference, also center, then circumference here. Same to this. Okay, now from there, what else are we having? If this one here is R and also this one is R, that means the angles which are opposite to them, they are also equal. That is an isosceles triangle. So if let's say this one is angle Y, even this one here will be angle Y, and this one here, let's say it is angle X. This angle here is the same as this one here. Even this one will be X. Are we there? So the same thing here, Y, then also here, Y. Now, from here, the reflex angle, let me begin. The reflex angle, AOB, okay, is equal to the reflex angle, we mean this one here, okay, AOB is equal to angles at a point, you know that they sum up to 360 or 2 pi, right? So we shall have that 2 pi, then minus the 2.8 minus this one, so it will give us this, right? Which actually gives us twice of X, not so? So meaning that X is going to be 2 pi minus 2.8, then divide by 2, which I can write as pi minus 1.4. Okay? Now, from here, I can now go further to find the value of Y, because they want the angle ACO. ACO. This is the angle Y. Not so? Okay. Now, we have triangle AOC being isosceles. Okay? It is an isosceles triangle. So meaning we shall have 2y plus x, which is equal to pi or 180 degrees. So our y is going to be equal to pi, then minus the x, which x is this one here. So we shall have pi, then minus 1.4, then we divide it by 2. So you can see that pi here can cancel with this one. Are we there? And then the minus that is here causes this one to be now a positive. Now 1.4 divided by 2, you get 0.7, not so? So this simply implies that angle SCO is equal to 0.7, which is in what? In radians. As simple as that. Then part B, find R in terms of the small r. Okay, now let us look at what we are having here. Since we know this angle here, we also know these two angles. I can use sine rule where we can say that sine of this angle over this length here is equal to sine of this angle over this length here. You see that? So I'm going to say that using sine rule, remember if a triangle is not right angled, then you can use sine or cosine rule. Now we have r over sine of the angle that is opposite to it, this x here, which x is this one. Okay, pi sine of pi, then minus 1.4. Then this one is equal to Now we shall go to small r, then sine of the angle that is opposite to it, y. So that will be r over sine of y, which we have gotten as 0.7. So meaning r here is going to be equal to, just cross multiply. So r is going to be equal to the small r, then sine of pi minus 1.4, then out of sine of 0.7. So that is that. Now I can get the value of this, and maybe I write it to 3 significant figures. So meaning r is going to be equal to what? Our calculator here has to be in radians. Mine here is in degrees, so I have to convert it. So radians, that is 4. Then now we have sine of pi, then minus 1.4. Then down here we have sine of 0.7. Okay, so we have 1.529684,375. So r, this capital R, is equal to 1.529684,375 of the small r. So I can leave it there, or I can say r is equal to 1.53 of r. That is to 3 significant what? Figures. So that is that. And then that is one way to do it. The other way to do it, I could also use the cosine rule. Okay, I could also use the cosine rule, because if I know this r, and this, I'm looking for this r, but then the angle that is opposite to that r is also known, then I can use the cosine rule. Okay, so I can have alternatively using cosine rule. So I'm putting for you these alternatives. For you, you pick what is easier for you. In the exam, don't do the same. That alternatively, no, use one approach. So we can have r squared, which is equal to, this r squared is equal to this squared plus this squared minus 2 times this, then cos of the angle that is opposite to this r. Okay, so we are going to have r squared is equal to small r squared, then plus again r squared minus 2 times r, then times r, cosine of the angle which is opposite to r, this capital R, is that x there. So meaning r is going to be equal to the square root of r squared plus r squared minus 2r squared, then the cosine of x, which we got here as pi, then minus 1.4. So what do we get here? This is 2r squared minus 2r squared cosine of this pi minus 1.4 under the square root. Okay, now from here r squared is common, so I can factorize it. That means here I will have 2, then minus 2, then the cosine of pi minus 1.4. You see that? Then the square root. You see that? Okay, now when I take the square root, I'll get the square root of this, then times the square root of that. So this one now will give us r times, because the square root of r squared will give you the r, then times the square root of 2 minus 2, then the cosine of pi minus 1.4. You see? Now we want to find out, does this one here give us this value that we got here? Okay, let's check. Remember, the calculator has to be in radians again. So we have square root, then 2 minus 2 cosine of pi, then minus 1.4. Close that bracket. What do we get? Do you see that it is the same thing? 1.529684,375. It is the same. So we therefore just conclude that r, the capital R, is therefore equal to 1.53 R. Part C, find the area of the shaded region in terms of R. If we check back here, this shaded region, we shall have area of this whole circle, not so? Then from there, we can subtract area of this sector. You see? I take off area of that sector. Then I have to also take off this what? Segment, which is equal to this segment here. You see? So that's what I'm going to use. I can say that the shaded area is going to be equal to area of the circle, then minus area of sector. The sector, I think it is CAB. This one has its center at C, okay, center C. Then minus 2, then times area of the segment, because we have seen that those two segments are equal. Okay, segment, let's say SC, or you take what? BC, whichever. This segment here, SC, this whole thing here. Okay, now what do we have as area of the circle? Of course, it is pi r squared, not so? Then minus area of the sector with center C. If we check here, area of the sector is a half r squared theta. But for this segment here, I mean for this sector here, the angle is this one here, 2y. But y, we have it as 0.7. So 2y will be 1.4. Are we there? Okay. Then its radius is this capital R. So when we go back here, we shall say it is a half, then capital R squared, and then the angle is 1.4. Then minus 2, then area of the segment, we have to get area of the sector. This is the segment. So I'll need area of this sector, then minus area of this triangle here. Okay, so to get the area of the segment, you get the area of the sector, then minus area of the triangle. Area of the sector is a half r squared theta, so a half. Then when I go back here, the radius for this sector is this small r, okay? And then the angle is x, which x is pi minus 1.4, okay? So I will go back here and I write r squared, and then the angle is pi minus 1.4. Then minus area of the triangle, a triangle which is not right angled. So long as you know two lengths, you have this length, you also have this length, and then you know the angle in between, then the area is going to be a half times A times B, then sine of the angle that is in between. So that means we shall have this triangle here is going to be a half, then times there is this radius and this radius here. Okay, then sine of this x that is in between here. Okay, so we shall have a half, then times r, that will be r squared, then sine of x, which x is pi minus 1.4. You see that? All right, now let's continue. This is pi r squared, okay, and then minus a half of 1.4 will give us a 0.7, not so, of r squared. Then when you multiply all through here, this one will disappear. So we shall have minus, then r squared into pi minus 1.4. And also this one times this one, we shall get a positive value. So that will be a plus, then r squared sine of pi minus 1.4. Okay, then from here, of course, we know that this capital R here is given in terms of what? Of R. Okay, so I can actually factorize R squared out, and then I can have this one as pi, then minus, this will be 0.7, then times the value. Remember, this one is 1 point, this one is 0.7, then 1.53 r. Okay, then we shall square it. So here I'll write 1.5. Actually, this one was having very many. Let me just leave them there as they were. So we are having 1.529684375. Okay, 1.52, okay, 968, then 4375. You see that? Of r. Okay, remember it is of r squared, but I've taken r squared outside. That means I'm not going to put the r here. Okay, so it will be like that. Then we shall have minus pi, then plus the plus 1.4. Remember, we are opening the brackets here. R squared is already outside. So plus the 1.4, then plus sine of pi, then minus 1.4, like that. Actually, I've forgotten to put here a square. Remember this part here. R is going to be squared, and then that 1.5 and the rest of those figures. Okay, so what do we get when we put in the calculator? And by the way, pi here can cancel with this one here. Not so? Yes, that one can go. Now we have negative 0.7 into 1.529684375. You square that, then plus 1.4, then plus the sine. The calculator has to be in radians. It is still in radians. Then pi minus 1.4. So we get 0.747 and the rest of those figures, but I'm going to write to three significant figures. That would be 0.747. 0.747 r squared to three significant figures. That is that. Remember, they told us to write it in terms of what? R.